Suppose you adjust your garden hose nozzle for a fast stream of water. You point the nozzle vertically upward at a height of 1.8 meters above the ground. When you quickly turn off the nozzle, you hear the water striking the ground next to you for another 2.5 seconds. What is the speed of the water as it leaves the nozzle? Okay, so for this, because it's a bit of a tricky question, let's draw it out. So this is going to be you. You've transformed into a stick figure, and you have your hose. So it's putting water up in the air, and then it falls down like that. So you hear it hit here 2.5 seconds after you turn it off. And it tells us that this distance is 1.8 meters. And then up here, velocity is going to be 0. So let's write out our constants now. So the initial, we don't know. T, we know, is 2.5 seconds. Acceleration due to gravity goes negative 9.8 meters per second squared. And our delta y equals negative 1.8 meters. This is because the change from where it starts to where it ends is just here. Even though it goes all the way up, it's still ending here. So its displacement is negative 1.8. So now we have to use an equation. Since we have 3 variables, that means we can use one. So the most common one, we're going to use the no VF. So delta y equals V naught T plus 1/2 AT squared. So negative 1.8 meters equals V naught, which we don't know, times 2.5 plus 1/2 negative 9.8 and 2.5 squared. So now it's just a matter of solving. So we'll plug those in. We'll do 0.5 times negative 9.8 times 2.5 squared. All right, so now we can subtract that. So we can do negative 1.8 minus answer. This means V naught times 2.5 equals 28.825. Now we can divide it. We can say that divided by 2.5. This means that our V initial equals 11.53 meters per second.